negotiation. Harry?
Thank you, Professor Lee. Good morning and thank you for joining us today. Bonjour, mesdames et messieurs. My name is Henry DeBey, and today I will be making the case for climate change adaptation funding needs for ocean resources. So since 1989, there's been a significant decline in world fisheries production. There's been a 233,000 ton decline in fisheries yield every year since 1989. This decline has resulted in a $182 million loss in revenue associated with fishing every year since 1989, or a total loss of $3.6 billion in revenue over the last 20 years. One main cause of this decline is overfishing. But as my presentation will show, fisheries are also increasingly being affected by climate change. This graph of Southwestern Pacific fisheries production provides a good example for highlighting the trends described in the previous slide. This significant decline in fisheries production is partly due to overfishing, and global climate change impacts to the oceans will only accelerate and exacerbate this trend. The three coastal ecosystems identified here, mangroves, seagrass beds, and particularly coral reefs, are all being affected by climate change. Fisheries depend especially on nutrients and organic material being exported from coral reefs. As coral reefs in the tropical oceans are degraded due to climate change, fisheries will also suffer. So these are the main threats to fisheries, global threats, I should say. Ocean acidification, ocean warming, and sea level rise. All of these physical impacts will reduce the productivity of the oceans and therefore will reduce fishery stocks and yield. What this graph shows in red is a consistent rise in atmospheric carbon dioxide over the last 50 years, which I think we're all familiar with, resulting in an increase in dissolved carbon dioxide, or carbon dioxide in the ocean, pictured in yellow. More carbon dioxide in the oceans lowers pH, which is a measure of acidity. So as pH declines, shown here in blue, acidity rises. So what this graph ultimately shows is that pH is declining, so the oceans are getting more acidic, and coral reefs, as the building blocks of fisheries, will invariably suffer. So atmospheric carbon dioxide concentration is expected to exceed 500 parts per million, and global temperatures to rise by at least 2 degrees C by 2050 to 2100. This will result in a loss of coral throughout the tropical oceans, and will subsequently result in less abundant fisheries that depend on coral reefs for food and habitat. We are currently above 387 parts per million. So if we continue business as usual, the slides on the right project what our oceans could look like. Not only will there be an increase in global average ocean temperatures, but there will be greater seasonal temperature variability. This graph shows how ocean temperature changes associated with El Nino and La Nina processes influence tuna migration. What is important to understand is that tuna migrate west during La Nina events and east during El Nino. Climate change will impact the predictability of El Nino and La Nina processes, and therefore the reliability of these extensive fisheries upon which many nations depend on. This graph shows in yellow the areas that will be affected most by climate change in the year 2060 in terms of ocean acidification and sea surface temperature rise. This yellow area comprises most importantly the South and Southwestern Pacific, the Western Indian Ocean, and the Caribbean. And as such, many small island states and developing nations in these areas will be affected by ocean acidification and ocean warming. This graph shows the countries, as opposed to the ocean areas, that will be most affected by climate change impacts to fisheries. Countries highlighted in dark brown are particularly at risk. So in conclusion, global climate change impacts to oceans are significant, particularly for small island states and developing nations in the Pacific, Caribbean, and Indian Ocean. For this reason, climate change adaptation funding is needed for these countries. This climate change adaptation funding should in turn be used to limit local impacts to oceans that can be controlled directly, such as overfishing and habitat destruction, including things like trawl fishing, polluted runoff and sedimentation, dredging, land reclamation, among other things. Thank you very much.